Welcome. In this video, we'll be diving into the world of database migration. Database migration involves moving databases between platforms or versions. Let's get started. So, what exactly is database migration? It's the process of transferring data between different storage types, formats, or systems. This involves moving data from one database vendor to another, for example, from Microsoft SQL Server to MySQL. It can also involve moving from on-premises to cloud environments, like moving your database to Amazon Web Services or Microsoft Azure. Migrating from an older version of a database to a newer version, such as from MySQL version 5.7 to MySQL version 8, is also database migration. It could also involve moving between different data models or schemas, such as moving from a relational database to a NoSQL database. The migration elements include schema, data, stored procedures and triggers and functions. Let's explore the different types of database migrations. First, there's version upgrade. This is moving from an older version to a newer version of the same database system. For example, upgrading from PostgreSQL 12 to PostgreSQL 15. Next, we have platform migration. This involves moving from one database vendor to another, potentially with different data models. An example would be moving from Oracle to MySQL, or SQL Server to PostgreSQL. Another type is cloud migration, where you move from on-premises databases to cloud-based database services, such as moving from an on-prem SQL Server to Azure SQL Database, or from Oracle to Amazon Relational Database Service. Finally, there's paradigm shift. This involves moving between different database paradigms or data models, like moving from a relational database to a NoSQL database or from a SQL database to a graph database. Now let's walk through the typical database migration process. The first step is assessment. This involves evaluating the source database and defining your requirements for the target database. Second is planning. Here we define migration strategy, timeline, and required resources. Next, we have schema migration, where you convert the database structure and validate the new schema. After that, data migration occurs. This involves the extract, transform, load process, also known as the ETL process, and rigorous data validation. After data migration comes testing. Here we test functional and performance aspects of the migrated data. Sixth step is cutover. In this stage, we decide on the go-live strategy and the downtime management. Post-migration involves monitoring the new database and performance tuning. The final step is documentation, where knowledge is transferred and lessons are documented. Let's explore different database migration strategies. The first is a Big Bang migration. This involves a complete migration in a single operation, with a defined cutover point from the source to the target database. It's simpler to implement since it does not require synchronization and has a clear cutover point. The downside to it is longer downtime, higher risk, and a difficult rollback. The other one is phased migration, which migrates database objects in stages, moving different tables or schemas in separate operations. The upside is its lower risk, easier to manage, and easier incremental testing. The downside is complex dependencies, longer overall time, and temporary interfaces. Parallel running is also a strategy. This strategy runs both source and target databases simultaneously with real-time synchronization until cutover. The advantage is minimal downtime, easy verification, and safe rollback. While the downsides are complex sync logic, higher resource cost, and data consistency issues. Zero downtime migration uses replication, CDC, or other techniques to ensure continuous availability during migration. The upside is that there is no service interruption. It gives business continuity and allows gradual transition. However, it can be highly complex, expensive to implement, and requires specialized tools. Let's explore some of the popular database migration tools available. First, we have the Amazon Web Services, AWS Database Migration Service, which is a cloud-based service for migrating databases to AWS quickly and securely. It supports both homogeneous and heterogeneous migrations, minimizes downtime with change data capture, also known as CDC, and offers schema conversion tools. Oracle SQL Developer is an integrated development environment for working with SQL in Oracle databases. It includes a migration workbench for non-Oracle databases, schema comparison and synchronization features, and data modeling and reporting capabilities. Azure Database Migration Service is a fully managed service for migrating databases to Azure data platforms. It supports online and offline migrations, offers assessment and planning tools, and supports SQL Server, MySQL, and PostgreSQL. MySQL Workbench is a visual tool for database architects, developers, and database administrators (DBAs) working with MySQL. It features a migration wizard for other database management systems, DBMSs, visual data modeling capabilities, and SQL development tools. SQL Server Migration Assistant is a Microsoft tool for automating database migrations to SQL Server and Azure SQL. It supports Oracle, MySQL, and SAP Adaptive Server Enterprise (ASE), provides assessment reports, and offers automated schema conversion. Flyway is an open-source database migration tool that strongly favors simplicity and convention over configuration. It supports version-based migrations, SQL and Java-based migrations, and provides command line and application programming interface (API) interfaces. Let's discuss some common challenges encountered during database migration and their solutions. One challenge is data compatibility, where you have different data types, character sets, and encoding between the source and target databases. The solution here is data type mapping, character set conversion, and validation testing before migration. Another challenge is downtime management, where business operations can be disrupted during migration, especially for large databases. The solution is to implement change data capture, CDC, parallel running, or zero downtime migration strategies. Schema differences can also pose a challenge, such as vendor-specific features, stored procedures, and triggers that don't translate directly. The solution involves schema conversion tools, refactoring code, and rewriting incompatible components. Finally, data integrity is a key concern, ensuring data consistency, completeness, and accuracy during and after migration. The solution includes checksums, row counts, data validation scripts, and comprehensive testing. Here are some best practices to follow for a successful database migration. Proper planning and assessment includes thoroughly analyzing the source database structure and dependencies, documenting all database objects and their relationships, identifying compatibility issues early, and creating a detailed migration plan with timelines. For data handling, clean and normalize data before migration, implement data validation checks, use checksums to verify data integrity, and archive historical data if not needed. Rigorous testing is also required. This includes creating comprehensive test plans, performing multiple test migrations, testing application functionality with the new database, and conducting performance testing under load. Timing and scheduling are important for minimizing impact. Schedule the migration during low traffic periods, establish realistic timeframes, include buffer time for unexpected issues, and communicate downtime to all stakeholders. Have proper backup and recovery plan by creating full backups before migration, developing detailed rollback plans, testing recovery procedures, and maintaining the source database until migration is verified. Finally, have proper post-migration plans which include monitoring performance closely, optimizing indexes and queries, documenting changes and lessons learned, and training the team on new database features. Let's look at a case study of an e-commerce platform migration. A large online retailer migrated from an on-premises Oracle database to AWS Aurora PostgreSQL. The data size was 5 terabytes, involved over 800 tables, and required over 3 months of timeline. Phased migration with parallel running was chosen as strategy. AWS Database Migration Service was used for data replication. The schema was converted using custom scripts, and blue/green deployment was done for cutover. The results of this exercise was 40% reduction in database costs, 30% improvement in query performance, and successful migration with only 4 hours of downtime. In summary, database migration is a complex but essential process for organizations looking to modernize their data infrastructure, reduce costs, or improve performance. Key takeaways include thorough planning and assessment are critical to success. Choose the right migration strategy based on business requirements. Testing is essential at every stage of migration. Data validation ensures integrity and consistency, and proper tools can significantly simplify the process. After a successful migration, focus on performance optimization, implementing proper backup strategies, monitoring and maintenance procedures, and training teams on new database features. This concludes our discussion on database migration. Thanks for watching. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.